Welcome everyone. Today we're going to do the calculations for the balloon length. Now, we're going to start with the circumference of the balloon. I'm going to do all the calculations for balloon number 1 to teach you how to do the calculations for balloon number 2 and number 3. Now, let's look at our data. First step is to find the largest circumference of balloon number 1. If we go down the list, the largest it was 25 centimeters, 25.00 centimeters. That's answer number 1. Number 2, find the radius, and it gives you an equation. R equals the circumference divided by 2 pi. Now, 25 is our circumference divided by 2 multiplied by pi. In this case, we're going to use 3.14. This gives us 3.98 centimeters. And there's our answer to number 2. Number 3 gives us the volume of the sphere equation. That's 4 multiplied by pi, 3.14, multiplied by the radius, which we just found, 3.98 cubed, we have to cube it, divided by 3. And this gives us our answer of 264 centimeters cubed. Now here's an issue. We don't want centimeters cubed. That's actually equal to milliliters. We want to convert this to liters. So every centimeter cubed is 1 milliliter. So that's 264 milliliters. And we have to convert that to liters. To do that, we're going to divide that by 1,000, which moves the decimal over 3 places, equal to 0.264 liters. And that would be our volume of the sphere. Now there's a reason why we did it in liters. That's because whenever we calculate the number of moles, that has to be in liters. So to calculate the number of moles, we need to use the ideal gas law. So the ideal gas law states PV equals nRT, also known as PIV-NERT. All right, so let's define our variables. So P, we're going to use the standard pressure, which is 1 atmosphere. Then for volume, we're going to use what we found in the question above, 0.264 liters. N, that is actually what we're trying to find. That's our question mark. R, that's a constant, 0.0821. And then T. All right, T over here. T, however, is, what is it? 23.5 degrees Celsius. Now the issue with temperature in ideal gas law, it needs to be converted to Kelvin. To do that, we will add 273, and that will make this 296.5 Kelvin. Now that we have the variables, let's plug that into our equation and solve for moles, or N. So we have PV equals nRT, which would be, if we rearrange this equation, we need N by itself. That's what we're trying to find. So we're going to divide RT on both sides to solve for, leave N by itself. So N equals PV over NR, or RT, sorry, RT. So P is 1, so we have 1 multiplied by V, which is above us, 0.264 liters, divided by R, 0.0821, multiplied that by the temperature, 296.5, and we get our number of moles, which is 0.0108 moles of CO2. That's our answer to number 4. And the final answer, the mass of CO2. To do this, we will take the moles of CO2, which we just found, and multiply that by the molar mass of CO2. So the moles, 0.0108 multiplied by the molar mass of CO2, which is 44.009. We do that, we get the grams of 0.475 grams. And that's the final answer. Now these last two columns on this page, you don't have to worry about. I hope this helped you solve for balloon number 2 and balloon number 3.